Hello, hello, hello.
Hey, how you doing?
I'm great. Can you hear me okay?
Yeah, can you hear me okay?
Absolutely. This is a rare event that both of us have a working AV setup right out of the gate. Oh, wow. That's awesome.
Yeah, they don't have like a setup mode, so that's kind of like probably why people mess up. But
Oh yeah, yeah. Just like I do a lot of these interviews and just most of the time something goes wrong. Microphone doesn't work, speakers don't work, something. But this is great. So, all right, we've got an hour. I want to make sure your time is well used. This is normally where I would introduce myself, but we're staying anonymous. So I am Fly Chinchilla for you, and you have been allocated the name Fresh Bear. So good to meet you, Fresh Bear.
yes, thank you. Nice to meet
Yeah.
you.
Yeah, me too. Great. So we've done an hour. Here's how I like to structure our time. We'll spend a couple minutes learning a little bit about your background to understand your goals.
Mhm.
We'll spend about 40 minutes doing a programming interview, and we'll spend about
Okay.
20 minutes doing a debrief. And so during the interview, I'll take a lot of notes. And for the debrief, what I'll do is I'll run through my notes as fast as I can. The idea
Mhm.
being that that'll give you lots of time to explore whichever topics you want to in more detail. Okay.
Perfect. Okay.
Cool. And the other thing, just a big picture thing here is I want to make sure you think about the next hour of your life. The goal here is for you to get some, so have fun, learn a little bit, get some benefit out of it.
Yeah.
Interviewing, real life interviewing is stressful. You're being judged. You want to get a job and all that. I totally understand. I've been a candidate too. But for the moment, you can sort of put that stress aside and just sort of have fun for the next hour. Okay.
Cool. Yeah. Thanks.
Cool. All right, so let's learn a little bit about you. Can you help me understand your background? Like, are you a recent grad? You're in school? You're 20 years experience in the industry, that sort of thing.
So I am currently employed at a company. I don't know if it's okay to say which one, but I'm employed at like um a large enterprise company.
Sure, sure.
And basically, I currently work on the tooling for front end development. So
Okay.
how that started was um, basically I started at this company for about 3 years ago, and then I was working as like a basically like a product on the product as a front end developer, kind of using the tools that I'm developing now.
Mm-hmm.
So these tools include like a CLI program that is used to basically build front end assets, and these assets are usually React, and these kind of plug into this micro front end architecture that our company has.
Okay.
So basically right now I'm focused on front end tooling, and I also uh, and that includes basically like a CLI that like over a couple thousand developers use, and then the CI/CD for all of the front end assets at our company. Um,
Cool. Fun stuff. And so from an interviewing perspective, so you've got, or help me understand, how long have you been working in the field?
let's say 5 years, about 5 to 6.
Okay.
Um,
And are you, in terms of interview practice, is this like the 10th practice interview you've done, or the first, or
this is
what?
actually my first one, and I haven't interviewed
Okay.
in 3 years. And the last time
Okay.
I had a coding interview, it went pretty bad, I would say. But it was also because I had like a week that I realized that I needed to study data structures and algorithms. And I am,
Mm-hmm.
so I have a degree in electrical engineering, and I took
Mm-hmm.
like maybe one class in C. And
Mm-hmm.
then I was a self-taught like PHP developer, web developer. But yeah, I went to school for something completely different, which
Sure.
was electrical engineering. It's still an engineering field, so that was helpful. But I basically became a self-taught developer after that, and when I graduated, I started working in software. So
Okay.
basically, I didn't ever study data structures and algorithms, and once I realized that's what you needed to do when you're interviewing for these top tier
Mm-hmm.
companies, it was a little bit too late, and so the interview went poorly. But now, I've studied the last couple, I've studied a good amount now on these data structures algorithms. I'll probably do a system design interview in the future
Hmm.
too, because I'm interviewing for Google in about a couple weeks. So, and
Okay.
they're probably going to ask me some system design questions because of my experience.
Okay.
Um, so yeah, basically, I'm just trying to prepare for that interview, and also trying to, uh, um, just practice my interviewing and kind of get used to the interview process. And yeah,
Okay.
I'm
Cool.
trying to land a job at Google. So,
Absolutely. No, that's really exciting. Just so you know, so my background, I also do not have a degree in computer science, and I
hmm.
did successfully study and pass the Google interviews.
Oh, okay.
So you should know it can be done, and there are plenty of people who work at Google who do not have computer science degrees, and they were able to learn the stuff. So have hope. You know, it's been done. Other people have pulled this off, so you can probably do it too. Great. Well, let's switch to doing this interview. Let's first of all make sure the editor works. Can you see me typing?
Yes, I can.
Cool. Do me a favor, type something in. Let's make sure I can see you. All right, cool. We can see each other. Great. Do you have a preferred programming language?
JavaScript. It's
Cool.
interesting they don't tell us. They don't tell us that. But yeah, JavaScript is my preferred programming
Oh
language.
yeah, sure. You see, there's a drop down top right. You can pick JavaScript.
Oh, okay, cool. Let's
Yep.
see. Ooh, well, I probably won't do TypeScript because that'll just take longer. But
Yeah, I mean,
okay.
honestly, it's whatever you're comfortable with, really. Um, cool. Okay, so we've got the editor, and I just want to point out a couple of things. So this editor will let you run your code.
Nice.
Um,
Okay.
Now, and actually, I'm just hitting the run button right now to prove to myself because I actually haven't used the JavaScript. Okay, great. So the JavaScript interpreter does work. Um, and so you're preparing an interview at Google. I believe Google does not use live interpreters.
It'll be a straight text
So
editor. So I don't know if it's better to just use a text editor then.
yeah, well, I mean, let's use the JavaScript editor just so we get nice syntax highlighting. That's be easier for you and me to
Yeah.
read it.
Okay.
It is true that the Google situation wouldn't actually have you running your code. So if you want to focus this practice interview to like faithfully replicate Google, then let's not use that magic run button, okay?
Maybe. Okay. Yeah, we won't use the magic run button.
Yeah,
I'll kind of just go through
yeah.
the code in line by line, and
Yeah,
we'll see
yeah.
how it goes.
Right. This is I will say unfortunately going to force us into doing that sort of line by line mental evaluation. And
Yeah.
personally, I love the live editor. I think it's awesome, and I think it's kind of silly. But I think there's a fair point here about replicating the Google interview experience. So, with that said, I am going to copy paste in a question for you.
Okay.
And let's do this thing, okay? And I'll keep an eye on time, so I'll call time. So I'm going to read this out loud to you, and then we'll take it from there. And I'm reading it out loud because that, in a real interview, that the interviewer would actually say it out loud to you.
Okay.
So, consider an auction. There are bidders in the audience. Each bidder is given a paddle with a unique number, for instance, 57. At the front, there's an organizer. When a bidder raises their paddle, the organizer sees it and recognizes the number. For instance, a bidder might raise paddle 78, and the organizer recognizes the number 78. Sometimes, however, a bidder accidentally holds the paddle upside down. For instance, a bidder with the number 68 holds it upside down, showing the number 89. The organizer assumes it's an 89, which is a mistake. We'll call any number that when turned upside down is a different valid number a confusable number. Can you write a function given a room with 800 bidders identifies all the confusable numbers?
Okay. So that is a very interesting problem. So I guess we could start off by let me see. So basically, we're gonna say that there's a room with 800 bidders, and these bidders are from it's starting from 1
Sure, we can start from
to
1. That sounds reasonable.
okay. So they start from 1 to 800, right? So 1 to 800, and then and so basically when you have a number that's turned upside down, so might raise paddle 78. So for instance, a bidder might raise paddle 78 and the organizer recognizes the number 78. Okay, so that's the normal case.
Mm-hmm.
But in the opposite side, basically they flip a number. Okay, so I see. It's actually literally like a mirror. it's not like, for some reason when I first saw it, it was, I thought that maybe they just reversed it. But so there's only a few numbers that are completely mirrored, right? So is it safe to assume that we could basically kind of look at 2, 3, 4, 5, 6, 7, 8, 9, right? And let's see if the number can be mirrored. So one is it, I'm gonna assume is it it's just gonna be a straight line, right? So that one
Sure.
can be reversible, right?
Agreed. Yes.
So okay, one could be reversible, and then two, I don't think if you flip two, you can't really confuse it, right?
Yes, I agree with you. That 2 upside down is not a valid number.
Okay, so 2 is not a valid number. 3, if you flip upside down, I think you can reverse that, right?
Well, if you've got paper in front of you, write down a 3, turn upside down, and tell me what you see.
Let me see. That's a good point. 3 upside down. It is not. I don't think it's a confusable number.
I agree.
4, I also don't think is a confusable number, but I could just double check on my end because it looks like an H. So I don't think. Same with 5.
Mm-hmm.
Yeah, I would say 5 is not confusable. 6 could be a 9. We saw that in the example. Can 7 be like a 1 or no?
I think let's say for this example that 7 cannot be turned into it. I can sort of see how you might think that because it kind of depends on how you write 7, but let's agree that 7 is not a valid number upside down.
Okay, and then we have that 9 could be 6 as well.
Agreed.
All right, so these are all the numbers that you can kind of see that are possibly confusable. So then, I guess like just so given a room with 800 bidders, right, identifies all confusable numbers. I mean, I would say that this is it's a pretty clear question, right? Like I'm trying to think of something that I could be missing, but do you think there's anything that I'm missing?
Well, why don't we explore space a little bit? What are your initial thoughts on how you might solve this problem?
I would say that we could basically, so that my first intuition says, like, let's list out all the numbers, right, from 1 to 800. So, and then we basically see which ones contain these characters, and if any of the numbers that contain those characters have a number in it that is confusable, then, or no, if it has any number that's not confusable in it, then it's not going to be confusable because then the bidder would know that it's confusable. So is it safe to assume that if any of the numbers like 2, 3, 4, 5 that are not confusable, is it safe to assume that the bidder, if he sees those numbers flipped upside down, he'll be like, he'll say, sir, your thing is upside down?
Yes, I agree with you.
Okay. So yeah, so I would say, we can kind of start going through, maybe we could kind of work through an example of like a smaller subset of numbers.
Mm-hmm.
So we can kind of go like, let's say 1 to 10. Oh, and then we also forgot 0, actually. So
right.
0 flipped upside down would also be 0. So that one would be thing. So let's say if we get, so yeah, what would be the inputs of this? Would the number just be the n? The number of bidders?
I think that's up to you. You could design this a bunch of different ways. The problem the way the problem is specified doesn't really doesn't require any particular implementation for how you want to specify that input.
Okay, so I would say let's say that the function takes in one argument, n, which is the number of bidders. I'm wondering, do you see the syntax highlighting or no? Or sorry, not syntax, but when I highlight a number.
Highlight the number and I'll tell you if I can see it.
I'm highlighting something right now.
I do not see any highlights, unfortunately.
Oh, okay. Okay.
That's too bad.
Yeah, nah, that's okay. I guess, but you don't see my cursor either, huh?
It's annoying. It's too bad I don't. Like, here, type something, and then I think I'll be able to see when you type. But
Yeah.
yeah, like when you type, it shows up, but like I can't see the blinking cursor, unfortunately.
Okay. So yeah, unfortunately, yeah, I was like highlighting stuff, but that's good to know. So let's say that basically we're writing a function, and the function takes in one number n. So like basically the function will be like identifies all confusable numbers. So let's say, do you want to like return the numbers in an array, or should we
That seems like
print them
a
out?
perfect. That's fine. Honestly, you can interpret identify as you want. Return them, print them out. That's all fine.
Okay. So let's just, for the sake of simplicity, let's just do it in an array. Or yeah, let's just do it in an array.
Yeah, that's fine.
We can easily switch that, I think. So then we'll say, const all confusable numbers, right? And that takes n, which is the number of bidders. So we could do num bidders.
Mm-hmm.
And I'm going to assume that, that number is not going to change. Like once you get the number of bidders, everybody's going to stay in that room.
Agreed. That's a very reasonable assumption.
Okay. So that's kind of like what I think the function outline will look like.
Sure.
But maybe let's kind of go through like an example. So let's say the input would be 10, right? Mm-hmm. So then in the array, the output would be 1 is confusable, right? 2, 3, 4, 5, 6, 7, 5 wouldn't be, 6 would be, and then 7 would be, and then 8 and 9 and 10. If you flip 10, what happens? So then you get 0, 1. So in this case with 10, would that be considered a confusable number?
So I think we can agree that if a number starts with a leading 0, it is invalid, and thus 10 is not a confusable number. Okay,
so if it starts with a leading 0, then it's not. So basically, if it starts with a leading 0, then it's not a confusable number. But would we agree that this list right here would be for the input equals 10, or n equals 10, whatever?
Sure, well, we can explore that in a little more detail. Why don't you walk through each one of those, and let's make sure that makes sense.
Okay, so 1, if you flip upside down, it could be confused as 1. 6, if it's flipped upside down. Sorry?
Can you do me a favor? Can you look at the definition of confusable again?
Yeah, let's see. Where's confusable? When, turned upside down is a different number. Okay. So 1 actually wouldn't be a confusable number, because if you flip it, it's going to be the same thing. And then the same thing with 8 actually. But the thing is that if 1 is in a different place though, then because like let's say we have 1, 2, so 1, 1, 1 would not be confusable, but 1, 2, 1. Yeah, so that wouldn't be confusable, but what about 1, 8, 1? That wouldn't be confusable, because when you flip it, it is it's the same number. But let's say you have 1, 1, 8 or 1, 1, 8, 1. Now when you flip that, you're actually going to get 1, 8, 1, 1. Mm-hmm. So I think this would be technically a confusable number, right? 1, 1, 8, 1.
Yes, agreed.
So the only time that it cannot be confusable is if a number is flipped, like if you flip it and it's the same thing, and if it's right in the middle. Like, so basically, it has to be right in the middle. Or there's a number like this, where if you flip it, there's basically, if it's all of these numbers, then it's a kind of like a palindrome. Okay. So in this case, 8 wouldn't be confusable. So it's only going to be 6 and 9.
Agreed.
Okay, so for the input 10, so let's go for an input of, let's see, do you think 20 would be a good one?
Sure.
So in this case, I think it would be everything from 10, right? So we could probably just do 6 and 9. And then 10 is not going to be confusable because when you have a leading 0. 11 is not confusable because it's the same thing. 12 is not confusable. I'm just going to start writing these out. 12, 13 is not, 14 is not, 15 is not, 16. 16 upside down would be 91. So I would say 16 is one of those.
Agreed.
So 16. What about 17 is not, 18 is not, 19 is going to be 61. And then what about 20? 20 is not.
Agreed.
Okay. Okay, so not gonna lie, that's this seems like a hard problem.
Okay, great. Lying would be bad, so yeah, that's cool. Okay, cool.
Okay, so now, so we know, but okay, one thing that we kind of can figure out is that, if it's gonna be inclusive. So 20 is gonna include everything from 10, right? Okay, maybe I'll extend it one more time to 30, and then let me just see. So we know it's going to be all of these, right? And then we're going to see 20 is not confusable. 21 is not confusable. 22 is not confusable. 23 is not confusable. 24, 25, 26, 27. So actually, as long as there's one number, so all the way to 30, there's going to be no more, because if there is one non-confusable number, like, so if a 2 is in there, so 1 is confusable, right? So that means that since 1 is confusable, that if all numbers are possibly, so basically if it's 1, 6, 8, 9, or 0, then we know that it's possible that for it to be confusable.
Agreed.
So, but since the input is 20, right? All the numbers between 20 and 30, are not going to have anything. And same with 40 and 50 and 60. No. And then once we get to 60, right? So this is actually inputs 30, 20 to, I would say 60, right? Yeah, up to 60. Inputs 20 to 60 is going to be this answer.
Yep.
So then input between 6, so let's just say input 60. Let's just do input 70, because then we'll get all those in there. So the output will start to be, so it'll be everything from the previous one. Then we'll get, 60. 61 could be 19, so 61. 62, no. 63, 64, 65, 66 could be 99, so 66. 66, 67, 68, could be 89. So it'd be, what did I say, 68? And then 69. So how many did we get? We got 1, 2, 3, 4 here. Right. All right. 70 onwards, we wouldn't get any. So let's just say 100 now.
Sure.
I'm still not quite seeing a pattern. I mean, I'm sort of seeing a pattern. So we need to know. So, okay, one thing we can try is, let's say we take all the numbers. If the number, we could kind of turn it into a string. And so let's say here, let me just write this out because I know you can't see what I'm highlighting. So we could basically go from 22, right? We know that each one of these digits, 22 could be, it's going to be 2 is not 2 is not confusable. So we just skip. So we move on. But anytime that all the characters are confusable, anytime all the characters are confusable, then it's a confusable number, right? But yeah, so I would say, okay, that'll probably get us most of the use cases, right? Because I unintentionally got 0 or 10 earlier, so, but we know that 10 is not confusable because you would have a leading 0. So yeah, let's see if this kind of algorithm will work for this. So like, for all characters are confusable, let's say our input is 70, right? And then our input is 70. So basically, let's take so one, we have our base cases of like 1 to 10. Those ones are gonna be basically like our sort of like base case, because 1 alone is not confusable, and 8 alone is not confusable, but the rest of them are. So like 1, 6, 9, and 0, or no, 1, 6, and 9. So I guess this is kind of like my naive solution of saying like all characters are confusable. If we basically we break down each number into its like characters, and if any of them are included as confusable numbers, then we do not print that number. Or if they are all confusable numbers, then we basically print that number, right? And so something like that would, so we basically have to iterate, n is going to be 100, right? So we have to iterate it over 100 numbers. So that's going to be at least big O of n. And we wouldn't use any extra space there. But then we would have those. It's going to be kind of it might be a little bit complicated to get all those edge cases. So like 10 would be an edge case. So I don't know. Maybe we got to break it down just a little bit further and say, is a specific number confusable, right? So like, does if we basically take a number, right? So is number confusable, right? and then we're gonna do like 100. Is this gonna be true? No, sorry, false, because it's gonna be 0, 0, 1.
I agree.
Okay. So I'm wondering, do you think we could do better than an O of n solution? And it's not only just O of n, we also have to iterate through each one of the characters. So it's a little bit more than O of n, but yeah, I would say I would still like justify that as O of n, because we're just iterating through each one of these, but then unless we get if we get a really large number, like an input of like 100,000, it doesn't grow linearly with the n it does grow linearly with n, but the number of characters doesn't grow linearly with n. So is it kind of safe to assume that parsing each one of these characters is kind of negligible compared to parsing throughout the whole array?
That's a reasonable assumption.
Okay. So yeah, I would say that is like kind of an O of n solution. I'm wondering if do you think we could do better than that?
There is actually, I don't mean to be coy about this. There is a solution that's more performant than O of n, but I think for the sake of time, I think it'd be more interesting to explore the current solution that you put together.
Okay. Okay, so let's go ahead and we'll go ahead and kind of implement this. So we can say that we'll go ahead and create this all confusable numbers, and we're going to basically return an array. So let's just call it the result, right? And then let's create like a little helper class called like is number confusable, or not helper class, but a helper function. So is number confusable, right? And that's just going to be a function that, it's going to be a function that, it doesn't have the auto. So it's going to be a function that basically takes in a number. No, we don't want to use, we'll just use a random number, or n, because numbers actually, it's already taken. So, and then in here, we're basically, what we're going to do is we're going to basically break down, we're going to take this and return this number to a string. So we're going to assume that, and this is just going to be like a string, or sorry, a number, an integer. Okay. So then we'll say that this is going to be a integer coming in. And the first thing we want to do is we're going to basically turn this into a string. So we want to go ahead and say number string. And then we'll just do n to string, right?
Okay.
And then we're basically going to say for each one of these, string.length I++. Okay, so we're going to iterate through each one of these guys, and we're basically going to say, we're going to look we're going to basically see if, we're going to basically see if if any of the characters are one of the confusable numbers. So,
okay.
So like if we can also make a little helper function, like we could be like, if is char confusable, do that. Like, you know, and then we'll just basically do number string of I. Did I not close that? Okay. So, you know, basically, and if it is char confusable, then basically, you know, we're gonna go ahead and return true, because we're basically saying, you know, is the number confusable? Because if any of the characters are confusable, then if char is not confusable, it's actually if char is not confusable, because then we're going to say that the number is confusable. Sorry, what is this is char confusable? It's basically any number. It's 2, 3, 4, 5, 7, or 8, or 0. So let's just go ahead and we'll go ahead and put this over here. Const is char confusable, and it's just going to be a character. Oh shit, I keep messing that up. And then we're going to do C. And then let's just make a const array of, you know, it's going to be chars. We could probably just do a set actually, but because then we won't have to have that lookup time. But let's go ahead and the char is the non-confusable chars are 2, 3. You probably just do 2, 3, 4, 5, 6. No, 6 is 5, 6, 7. 7 and 9. Okay. And then if any of these, so basically if C or if chars that includes C we're going to go ahead and return it's going to return so this is char confusable. So actually this should be the opposite. This should be it should be the is char not confusable, because so we want to do 1. We were saying that 1, if you flip it, it's fine, but there's some weird use cases there. 1, 2, 3, 4, 5. 1, 6, 7. Okay. We have 1, 6, and 9. Actually, the only 2 are 6 and 9. So if it is, then we can return true here. Number string. Okay, so if the char is confusable, then we can go ahead and return true. Because if we find, oh shoot, so no, we didn't, otherwise return false. So we're going to go ahead and say, is number confusable? If any of the numbers in here are confusable, then we're going to go ahead and or if they're not confusable, then we're basically going to say that, so this is confusable. So, sorry, I'm getting a little bit confused because we're talking about confusable.
Sure.
But yeah, so basically, is the number confusable? If it is, it is when all of the characters are going to be, when all of the characters are confusable. But actually it needs to be, so the thing is it's the opposite of what you wanted. Like, we want to basically check if it has any of the regular numbers in there. So 2, 3, 4, 5, or 7. So is not mirrored, or is not confusable. So we'll say it's 2, 3, 4, 5, 7, 7, 8, 9, right? And then if the char includes not, then we're going to do that. So then is not confusable. So basically, if any of them are not confusable, then we're going to return false. Otherwise, we want to return true. Because we want to basically, because we know if any of these numbers that go through it are, if any of these numbers are normal numbers, like that are not mirrorable, then we know that the bidder won't be confused. And and then, so let's say, like right now I know that this is not accounting for the edge cases right now, but I'm gonna just go ahead and go to the next part, just because.
Well, let's take a moment there. We're kind of at time. I want to ask you about one possible value, and then I think we can shift to doing a debrief if that's okay.
Okay.
I'll just write the number up above here. Okay.
Yeah.
Oh, sorry. So tell me about the number 69. Is 69 a confusable number?
By the definition, 96.
Is that right?
No, I would say because you flip it and you would flip it and it would be the same number, so it wouldn't be confusable.
Agreed. And looking at your implementation, what would your implementation return if we asked it to tell us if 69 is confusable?
Right now, it would say that. Right now, it would basically say that, 69 is a confusable number because it doesn't contain any. It doesn't contain any numbers that aren't like confusable.
Right. So, okay, cool. Let me write one more thing down here. It's just my own notes. All right, great. So let's shift to. We got about 17 minutes. Let's use that to do a debrief here. Okay.
Cool.
So So first of all, thank you very much. I know this is like weird and crazy and fun and stressful and all that. And you know, it's taxing to go through this. So I appreciate you giving it a shot. Okay. So what I'm going to do is I'm going to read through my notes kind of rapid fire, and then we can dig into whichever ones you think are more interesting. Okay. And I want to make sure we focus on like concrete stuff, like so you understand what you're doing well, you understand what things you should work on in the future. Okay.
Yeah.
Great. So let me run through this. All right. First of all, up front, you did a good job clarifying an assumption about whether or not we're looking at like what the numbers of the bidders were, and so you clarifying that we're going from 1 to 800. I appreciate you bringing that up. That's good. This question is deliberately ambiguously specified, so it's helpful to clarify that. I appreciate you talking through the problem statement. It's a really good technique to sort of restate the problem in your own words to make sure you've understood it. I appreciate your conversation about your discussion of whether or not the digit 1 is reversible. There's some subtleties to that. Basically, a lot of candidates will sort of observe that depending on how you write a 1, it may or may not be reversible. But so I appreciate you bringing that up. And similarly, good job focusing on digits up front. Digits are really the sort of core aspect of this question. And it's great that you went right to that. So well done. You did, when you were originally going through the list of digits, you forgot about 0. You realized it later and you added it back in. Normally, I wouldn't care that there's a bit of a pattern here. I'm going to point it out that plays into though. There's a certain point in your implementation where you said, "Hey, this seems pretty simple. Am I missing something?" If you ever have to ask, "This seems simple. Am I missing something?" the answer is probably going to be yes. It's very rare that a question is deliberately simple. I mean, it's happened. It has happened, right? So I don't want to be like totally, 100% on this, but like, yeah, no interview question is fundamentally a simple one. Because mainly those aren't fun. I don't think they're very interesting as an interviewer because you don't really get to explore things. And I honestly, as a candidate, I don't think they're fun either. So just, if you're like, "Oh, this seems simple, I got it," like, take a breath, take a fresh look. Yeah, there's something more complex. And don't get me wrong, like, if a candidate said that and then was like, "This seems simple, I'm sure I'm missing something," I'm not going to knock it. It wouldn't be a point against them. Like, I get that. Okay. The one thing you started doing, and I encourage you to do more, is write down your assumptions. So as you're talking with me, clarifying your understanding of the problem, you've got an editor right in front of you, write down your assumptions. You did that for some things, but you didn't do it rigorously. So it's great that you got the instinct to do it, so I'm just encouraging you to do it more. I think you did a great job thinking out loud. I don't think there was even a single moment where I had to say, "Hey," it was like one of those awkward silences where I wonder, what is the candidate thinking? You were really good. Good pacing, good enunciation. I really appreciate it. I appreciate that you asked about input-output parameters. That's really great. You said at a certain point, like, "Hey, are we getting an input? Like, can we return an array? Is that cool?" Yeah, that's great. It's nice you brought that up. The failure mode with that is candidates who not only don't bring it up, but then like when they actually get to writing their code, they just haven't thought it through. And then they're like, "Oh," they get to the end, like, "Oh, right, I got to return something. Oh, crap, I didn't, I forgot to account for that." But anyway, you didn't do that. That's great. You also identified one of the major edge cases, which is numbers that invert and end up with leading zeros. This question is full of edge cases. No candidate has ever gotten all of them. Some candidates get some of them, and I appreciate that you noticed that one right away. So well done. You kind of missed the definition of a confusable number, right? You missed that bit about it being different. Remember when I asked you about, like, is 69 confusable? Or I think I asked you, like, is 11 confusable? And you're like, "Oh," and so there's like that's subtle, but it's important. Like the definition of confusability, it's written in the question very deliberately. Like each one of those actions is different valid number, right? So it's important to get those. Let's see. There's actually so a related note. One time when you were walking through test cases, you like listed out the numbers from like 1 to 20. And I know again this seems little, but you missed one, which is 18. The reason I mention this is I noticed a certain lack of thoroughness in some cases. Now, thoroughness in any given one, in one instance, if there's only one, I wouldn't care, whatever, people get all details. But I feel like there were enough instances where you were like listing things out, where you like miss examples. That suggests to me that you could probably spend more time on that, like developing more self-discipline. So like especially anytime you're enumerating a thing, like that's definitely the time to like really be thorough about it. And again, like each individual instance, I don't really care, but it's the aggregate number of them that ends up being like a bit of a red flag as a candidate.
Okay.
Now, furthermore, I was really pleased you did get to a certain point where you wanted to use examples to think it through. Remember, you did that thing. You're like, "Okay, let me look at the ones 1 through 10, 1 through 20, and 1 through 50. That was really cool. Like it was nice to witness. You were thinking things through. I think it's a really nice technique. I appreciate it. I really appreciate there's a certain point in your solution where you're like, you had an idea for a solution and you stopped and you asked me, like, okay, should I, the candidate, keep going with this, or do you want a more performance solution? I think it's great that you asked me that question. I love it. I love that you gave me the opportunity to say, yep, there's a more performant one, but no, let's continue this current one. Like, that's awesome. Like, it's great that you signaled like an awareness of performance as an issue, but you also didn't, like, you gave me, the interviewer, an opportunity to kind of set the direction I wanted to go in. I think that's great, and actually very few candidates do that, so I think it's wonderful. And the last thing, because we were just talking about this, but I think with that case about 6-9, like, sort of misunderstanding what turning something upside down looks like. We already talked about that. So this gets us to the end. So in a Google interview, the interviewer is going to give you a score between strong no hire and strong hire, right? So the ratings are strong no hire, weak no hire, weak hire, and strong hire, right? If I were giving you official rating, I would probably give you a strong no hire. Let me explain why. I want to make sure that you leave this interview with your self-esteem intact here, okay? But you should still get a pretty.
This is why I'm doing this, because I
exactly.
knew I'm going to fail.
Yeah. Failure is just an opportunity to get better the next time, right? Okay, but here's why, right? Ultimately, you didn't finish a solution in the time. That's really why, right? And there's a bunch of reasons why that didn't happen, and that's what you and I are working on together today. So it's a basic precondition, right? Now there is like a slight exception to that, which is if I have a candidate who just clearly has a very robust solution in their head, and like the code isn't finished, but like it's close to finished, and it's like very, very clear to me that like 30 more seconds this would have been done. Then I might still go with a higher recommendation. But most of the time, the candidate doesn't have a working solution by the end. Like no, it's just going to be a strong no hire. There's almost no exception to that. So let me stop myself there because I want to make sure you get some real actual feedback here. We got about 10 minutes. What aspects would you like to talk more about?
I don't know. I just honestly want to figure out like what I could do better, which like where was I inefficient? I understand I need to be more thorough, which I can work on. How can I practice? So I mean, I'll probably sign up for another interview, like or two.
By all means. Yeah, well, I mean, I'm sure interviewing.io will be happy to take your money. Sure. Let's give you some concrete suggestions here. Okay. All right. Now, first of all, I actually think that there's a lot to be very optimistic about here. Okay. So you're a great communicator. You clearly are comfortable in JavaScript, and I don't think and clearly these kinds of problems, these algorithm problems, you seem to be sort of intellectually comfortable with them. I didn't see you fundamentally wrestling with them seeming foreign. So these are really great, and these are signs you should be optimistic. So let me give you some concrete suggestions here. Okay. One is I want you to think of the interview in a more structured fashion. Think of it as a couple stages. First stage is interviewer presents question. Next stage is candidate refines their understanding of the requirements. And we'll talk about what that looks like. Next stage is candidate comes up with a design algorithm for the solution. And then the last stage is candidate implements that. So the more you think about it as a structured sequence of stages, the more you'll focus in on each one of the stages and get better at them. What I have observed with you and with other candidates who tend to underperform is the stages kind of overlap each other too much. They bleed into each other. And as a result, the way you use your own time becomes less efficient. So one thing I want you to do is really start thinking about this as these structured sections. What you can control is refine the requirements, present and figure out an algorithm that'll work, then implement. And the more you can do those three things in a structured way, it'll be better. Now let's talk in more detail. Refine requirements. The number one thing you can do to improve your understanding of requirements is enumerate test cases.
Okay, so one was interview presents questions. Two is refine understanding.
Yes.
Okay.
Oh, by the way, I'm going to write this. I'm going to provide notes to you here. So I'm writing.
Okay.
Oh yeah, you will get very thorough notes from me. Don't you worry.
Okay, cool.
Yeah. I'm writing this down. algorithm definition, algorithm implementation. Okay, so let's talk about requirements. The number one thing you need to do is go through more test cases. Enumerate them, read them out, talk them through, and understand them. So, for instance, you actually did this a little bit in a way that other candidates have not. I was actually really pleased. You initially wrote out numbers. You remember you did like zeros, like 1 to 10, and you wrote out like, it was like 1, 6, 8, and 9, and I actually pushed back on it. I said, well, tell me more about 1. And you said, oh, well, 1 upside down is actually still 1, so that's actually not confusable. That's cool. And actually, very few candidates do that. And that was really cool, and that was an opportunity for me as an interviewer to see that you had enumerated a case, and there was our opportunity for us to think it through in a little more detail. So my recommendation is to do more of that, right? I think that you had to spend a couple more minutes, kind of challenging yourself, just list a bunch of numbers. It's not too hard to say like, oh, okay, 1-800. What are some numbers that are interesting? Well, and you could start throwing some out. Just like do it a little bit more and force yourself to think through it, and that will absolutely help you gain more clarity about what your solutions are. Okay. The next thing is the algorithm definition. I think that I see that happen with a lot of candidates. You have an idea in your head roughly. You're like, I'm going to loop from 1 to 800. I'm going to look at each one. I'm going to kind of figure out if each one is confusable. But I think if you apply a little bit more rigor at this stage, and in this case, like write it out in a pseudocode form or comments or something. Like write out the algorithm that you plan to do. You're going to help yourself a lot. You're going to help yourself think it through. You're going to help me, the interviewer, understand your thinking. You're going to give both of us a roadmap for where your implementation is going to look like. And you're going to immediately see more edge cases. As soon as you put together that algorithm and look at it, the edge cases will present themselves to you much more readily. Okay. Now it comes to implementation. But JavaScript, you wrote it reasonably quickly. You're clearly comfortable in the language. I think you tripped yourself up a little bit on like some of those knots and knots, knots with the knots with the knots. So I'm sort of not surprised. This is the logic behind this solution always ends up being a little bit thorny. But I think that so one of the things is if you write out your algorithm in pseudocode as comments, then you sort of copy paste that and you turn that into real code. And if you're working off a template of your own comments, you will write code more efficiently. I see. Right? If you do those things, you are likely to overall perform more efficiently and end up with working solutions by the time time runs out. Okay. Sweet. Okay, that's really helpful. I think this is honestly a really good. I'm really happy I did this actually. Cool. It makes me happy too. I want to make sure you get some value out of this thing. Yeah, it's a little demoralizing that I did so bad, but I mean, in my opinion, I did pretty right. We can explore this a little bit because I don't want you to come out of this and you get home at the end of the day and you're like, that sucked. Okay, look. First of all, don't beat yourself. Exactly what I wanted. So yeah. No, look, you and I are actually the same boat. I don't have a CS degree either, right? This is what you practice for. You do a lot of things well, and you have all the aptitude. So this is really mostly about practice and self-discipline more than it is about there's just some fundamental CS skill that I don't have. That's not what I saw here. What I saw is all the aptitude's there. You just have to practice a bunch of these, and I think you're going to be really good. Yeah. So I have been practicing on LeetCode, and I've been kind of going on the blind 75 or something. And then but I definitely probably need more rigor on the actual process. Yeah. Well, so this is I've done LeetCode and HackerRank too, and I do think they're a good practice, but they are not the same as practicing an interview with a real interviewer. They really aren't. They don't have the same subtlety, the same kind of communication patterns. I also think that the examples on LeetCode and HackerRank are almost too perfect. They're not I try to make these, I ask these interview questions that are a little bit messy with a bunch of weird edge cases to them. And I found that the questions on LeetCode and HackerRank they're almost too clean. They're like these beautiful textbook questions. And they're actually not quite what you're going to get asked in a real interview. And by the way, with that said, go ahead. Is this more of a phone screening question, or would this be, or interview, or would this kind of just be representative of the on-site interview? Well, this is definitely on-site interview. This is way too complicated for a phone screen question. Way, way, way too complicated. Phone screen questions are going to be a hell of a lot easier. I know we have 15 seconds left. That's why I cut you off. But I wonder.
But yeah, like I have basically like 3 more weeks. Does it end right at 5?
You know what? I'm happy to run over for you. It's no problem, buddy.
Okay. Thank you so much.
Of course.
Yeah, so I'm wondering, like, I have about 3 weeks until my like phone screening interview, and then I'm definitely gonna drag it out like as much as I can before the actual interview. Like, cause also I have like a ton of stuff at work I need to do too, so it helps out with that. I'm just wondering, like, what's like how can I mean, honestly, I think this was really helpful. I might do one of these like a week, but also I think what do you think is like the best preparation like I could do? Like, do you think I can like, do you think I should just basically kind of go through problems as if they're like actual interviews, and kind of time myself, and then break it down into those 4 categories you're talking about, like the presenting, the refining, the algorithm. So you're saying is presenting, refining, and then the algorithm implementation, and then the analysis, or what was the order?
Oh, sorry. Well, it's a requirement. I mean, the interview asks a question. The first thing you need to do is narrow down what the requirements are. The next thing is design a solution and then implement a solution. So design.
Okay, so then design solution and then implement solution. And then it's in the design where you want to kind of like see, are we on the same page if this is like the solution we kind of want to go through. Like because you said you appreciated that.
Absolutely, yes. Well, and I'll tell you specifically about Google. I can't speak for other companies. The Google interviewer is most interested in you coming up with a working solution, not the best solution, but it's much. If you come with the best solution, that's awesome by all means. But like, I don't know if you've heard the phrase "Don't let the perfect be the enemy of the good." But that is definitely the philosophy of the Google interview. So like, they're much more interested in can this candidate come up with something that solves the problem. Oh, good, they did it. Great, let's hire them. Or, oh, they did it, and then we had 5 minutes left over, and we both theorized about like what a better solution would look like. Or a very, very rare case, oh my God, the candidate came up with an incredibly performant solution up front. That's very rare, and it's just
okay. I see.
But I want to answer your question. Really, was like, you got 3 weeks. What do you want to do? My recommendation is, I mean, live your normal life, do your job. You have to get through things day to day. Practice interviews as much as you can, as much as like you both logistically can, and as much as you emotionally can. Like this is, it's a lot of mental stress to go through to do this. So if you do one a week, that's fine. If you do one a day, that's even better. But just don't kill yourself. Take care of yourself. Like day before the actual interview, like sleep well, have a good breakfast, that kind of thing. You got to always remember when you get to that final lap, like don't try to cram it in. Just relax.
Yeah.
Relaxation will help you perform better than anything else. My recommendation is try to focus on building the self-discipline around understanding the stages of the interview. I think you're going to help yourself a lot.
Okay. And you think timing myself during like, because I still feel like there's still a lot of stuff I need to learn on the leak code side. Like, you think kind of just going through the structure, because a lot of the times I'll run into a problem like, what was the problem I was reading? Like the course schedule, but like there's like 3 different ways. Like there's so many different ways to implement it, And then I kind of get stuck on like trying to understand like, okay, what is topological sort, or like why would I do this depth first search versus breadth first search, or like do you think it's better to really spend a lot of time on each question and understand each question like really thoroughly, or is it kind of better to just treat each question as if it's an interview and kind of go through the structure and then see how I can go through that?
I think breadth is better than depth.
Breadth meaning
do a wide variety of problems. I think it's actually a better preparation. You gotta do a Google interview, they're gonna do 5 interviews for you. 4 or 5, whatever they do these days. And it's gonna be a wide range of stuff. So the better preparation is to prepare on a wide range of training material.
Okay, and one of those. So should I treat each one of those kind of like an interview in itself?
Yeah.
Yeah. Okay.
Yeah.
Okay.
Cool.
All right. Well, yeah. Thank you so much for the extra time.
Yeah, of course, no problem. Best of luck. I'll see you on the internet. Yeah.
Yeah. I mean, there's no way I can like request like a specific person.
Oh, I'm flattered. You're the first candidate who's asked for that. Well, I'll tell you what. There is. I'll tell you what I'll do. When I click end interview, when I do the feedback, there's a field that says, "Do you want to share contact info with the candidate?" I will say yes, and you can say yes, and then you'll have my contact info, and then you're welcome to follow up if you'd like to. Okay.
Okay. Thank you.
All right, no problem. I'm going to send the notes in 30 seconds. I'll see you around. Okay.
Okay. Thank you so much. Bye.
Of course. Cheers.